For today's assignment, we are tying it all together. So what I mean by that is now that you have learned 4 different methods on how to solve a system of equations, I want you to look back and practice all 4 methods. So remember, you learned the graphing method, the substitution method, the elimination method, and then matrices. So I'm going to go ahead and get through this video. I'm going to do one question from each section just to refresh your memory. So let's go ahead and look at number 3. So in this first section, we are solving a system by graphing. So remember, whenever we are solving or whenever we are graphing an equation, it has to be in slope-intercept form. So remember, that is supposed to be in the form of y equals mx plus b. Both of my equations here are in standard form. So I'm going to go ahead and take the first equation, x minus 4y equals 28, and I want to solve for y. So remember, when we are going from standard form to slope-intercept form, there are 2 steps. Move x, so I'm going to subtract x to both sides, and I'm going to end up with negative 4y equals negative x plus 28. And our last step is to divide by the number in front of y. So here we are dividing every single term by negative 4. And I end up with y equals. Remember, here in front of x, anytime you have a negative sign and there's not a number here, it's understood to be negative 1. So I am pulling negative 1 over negative 4 apart from x, and I end up with a positive 1 over 4x. And then 28 divided by negative 4 is a negative 7. Now I also want to go ahead and solve the second equation. We have x plus 2y equals negative 2. So again, 2 steps, move x, and I end up with 2y equals negative x minus 2. Last step is to divide every single term by the number in front of y. So here I'm dividing every single term by 2. And I end up with y equals negative 1/2 x minus 1. So now I want to go ahead and graph both of my lines. So here for my first equation, again, we have y equals 1 over 4x minus 7. So my y-intercept is at negative 7. So 1, 2, 3, 4, 5, 6, 7. And then my slope is 1 over 4. So whenever my slope is 1 over 4, this tells me I should be going up 1, right 4. So from my y-intercept, I'm going up 1, right 4. Up 1, right 4. Now remember, you also have to go in the opposite direction. So we're going down 1, left 4. Your slope is negative 1/2, and your y-intercept is negative 1. So I'm going to start off by placing a y-intercept at negative 1. And then because my slope is negative 1/2, this tells me I should be going down 1, right 2. So from my y-intercept, I'm going down 1, right 2. Down 1, right 2. Down 1, right 2. Down 1, right 2. Now I'm going to go in the opposite direction. I'm going to go up 1, left 2. And from there, we're going to go ahead and connect the dots. Extend our line and put arrows at both ends. Now guys, when you are finding the solution to a system of equations, your solution is always where your 2 points intersect each other. So here our points intersect each other at this point, which is at 8, negative 5. So 8, negative 5 is my point of intersection. So on this assignment, you are to complete numbers 2 and 4. So in the graphing section for topic 1, you are only required to do numbers 2 and 4. Okay, now when it comes to the substitution method, remember when it comes to the substitution method, guys, one of your equations has to be solved for either x equals or y equals. So let's go ahead and take a look at number 7. So number 7, both of my equations are in standard form. And so we need to solve one of our equations. So here I can either solve the top equation for x or the bottom equation for x. Personally, I think it's going to be easier to solve the bottom equation. So here I have x minus 2y equals 1. And the reason why I want to solve for x here is because x is already by itself. I already have a coefficient of 1 here. So what I'm going to do is I'm going to go ahead and add 2y over to the other side. And I end up with x equals 2y plus 1. So guys, now I know that x is equal to 2y plus 1. I know that they are equivalent to each other. So what I'm going to do is anytime I see an x value in the opposite equation, I know that I can substitute it in with 2y plus 1. So here, this is going to become 2y plus 1 plus 4y equals 19. Now all I have to do is solve for y. So our first step is going to be to combine like terms. So I'm going to combine my y's together. So I have 2y plus 4y, which ends up giving us 6y. I'm going to drop down that constant of plus 1, and this equals 19. My next step in solving for y is to remove the constant. Instead of adding 1, I'm going to subtract 1. And I end up with 6y equals 18. My next step is to divide both sides by 6, and I end up with y equals 3. Now, my next step is I have one part of the coordinate. I have the y value. I now need to find the x value. So I now need to come back over to my two original equations, and I need to decide which equation I want to substitute in the value of y for to find the value of x. In this case, I'm going to go ahead and use the first equation, x plus 4y equals 19. And remember, I know the value of y. I know that the value of y is equal to 3. So anytime I see a y value, I'm going to substitute it in with 3. So this ends up x plus 4 times 3 equals 19. 4 times 3 is 12. My next step is to subtract 12 to both sides. 19 minus 12 ends up giving us 7. So here, my coordinate, or my solution, ends up being 7, 3. In the substitution in topic 2, you are only required to do numbers 6 and 8. Now moving on to the elimination method. So remember, with the elimination method, in order to use the elimination method, you have to have opposite coefficients. And so remember, opposite coefficients are things like 6x and negative 6x. If you do not have opposite coefficients automatically, you have to create those opposite coefficients. And really important, whenever you are looking at solving a system using opposite coefficients, your equations have to be in standard form. So we're going to go and take a look at number 11. So number 11, we have 7x minus y equals 19, and we also have 2x minus 3y equals 19. So they are both in standard form. That's great. So now I want to check for opposite coefficients. I look at my x's, I notice that they are not opposite coefficients. I look at my y's, I again notice they are not opposite coefficients. So from here, you know that you're going to have to create an opposite coefficient. So your next question is to check to see if your coefficients go into each other evenly. So in other words, I know that 2 does not go into 7 evenly, but I do know that 1 does go into 3 evenly. So what I'm going to do is I'm going to create opposite coefficients for my y values. Now, here, you always want to pay attention to the larger coefficient. So here, I need to find the opposite coefficient of negative 3y. And the opposite coefficient of negative 3y would be a positive 3y. So now I need to determine, what do I need to multiply negative 1 by? What do I need to multiply negative 1 by to create a positive 3? So I know that a negative times a negative equals a positive. And so therefore, I know that I'm going to need to multiply the top equation by negative 3. So negative 3 times 7 is negative 21x. Negative 3 times negative 1y is a positive 3y. Now this equals negative 3 times 19. And negative 3 times 19 is going to end up giving us negative 57. Now I'm going to go ahead and bring down the second equation. And now I can go ahead and add these two together because we have now created opposite coefficients. Now remember, when you create opposite coefficients, these terms eliminate each other. And now negative 21x plus 2x gives me negative 19x. And this equals negative 57 plus 19, which gives us negative 38. My next step is to divide by negative 19. Negative 38 divided by negative 19 ends up giving me a positive 2. Now that I know that x equals 2, I want to find the value of y. I'm going to go ahead and use the bottom equation, 2x minus 3y equals 19, to find the value of y. Now again, remember, I know that anytime I see an x value, I'm substituting it in with 2. 2 times 2 is 4. Subtracting 14 of both sides. I end up with negative 3y equals 15, dividing both sides by negative 3. 15 divided by negative 3, I end up with y equals negative 5. Now I want to go ahead and write my answer as a solution. We end up with 2, negative 5. So from topic 3, you are required to do 10 and 12. Moving on to the next page, we are looking at solving systems using matrices. That were absent on Friday, we learned the last method, which was solving systems using matrices. Now, when you are solving a system using matrices, you need to make sure both of your equations are in standard form. And we're going to go ahead and take a look at number 1 for this example here. So you need to make sure that both of your equations are in standard form. So remember, that's ax plus by equals c. So I noticed that both of my equations on number 1 are xy equals a number. And so in that case, this is ready to go to use matrices. So remember, when I'm using matrices, my first step is going to be to open up a calculator window. And from here, we're going to go ahead and press menu 7, 5, and then menu 7, 1, 1. We're going to press tab and we're going to change the number of columns to 3. And all we're doing is entering in the coefficients of each variable for each equation. So on the top row here, the coefficient for x is negative 8. Then the coefficient for y is 2. And this is equal to negative 8. Now looking at the bottom row, my coefficient for x is 16. My coefficient for y here is 6, and then this is equal to negative 24. Now when I press enter, I get back the identity matrix. So remember, that's 1, 0, 0, 1. So this lets me know that, remember, it's x, y equals a number. So here this lets me know that x equals 0 and y equals negative 4. So here my answer or my solution to number 1 would be 0, negative 4. Now unfortunately, I had to switch over to my laptop to show you the Inspire, so I'm unable to write on the paper. But on this paper, using matrices, you're only supposed to be doing the evens. So 2, 4, 6, 8, and 10. You do not have to do the odds. But again, make sure both of your equations are in standard form. Now you will be working on this handout if you have no missing work. So if you have any missing work, please make sure you get that completed. And I will see y'all when I see y'all.